this is just a chapter review sort of thing, and so there was just a few things that I kind of wanted to go over because our test is coming up pretty soon.
All right.
But so it's the trigonometry, or the first thing I wanted to go over was just like right triangle trigonometry, just because, I mean, I'm pretty comfortable with it. It's just sometimes like with the cosecants and secants and cotangent.
Yep.
That's
okay. Go ahead. Give me your questions.
So what we have to do is evaluate the 6 trigonometric functions of angle theta.
Okay.
And so for the first one, it's a right triangle with the 2 sides being lengths 12 and 16.
Okay.
And then it leaves you to solve the hypotenuse. And you have to find angle theta, which is nearest line 16.
Which is opposite side 16 or adjacent?
It would be the other angle that you have on there now. So instead of being...
So if I make this 12 and this 16, I'll have it right?
Yeah.
Okay. Let's do it that way. Okay. And they want those all 6 trig functions of theta.
Yep.
Okay. Well, first of all, let's solve for the hypotenuse.
Okay.
Now, you can do it the hard way, which would be the square root of 12 squared plus 16 squared, which you would need a calculator for. Or you can do it the easy way, which is to recognize that we're looking at a 3, 4, 5 right triangle, or are we? Yeah, we are. So everything is 4 times bigger than a 3, 4, 5 right triangle.
Okay, so that just make it 20?
So that makes it 20. In other words, that saves quite a bit of time and doesn't require a calculator.
All right.
Okay, so now the fact is we can do all 6 trig functions of theta without knowing theta. Let's just do that, and then I'll show you how to solve for theta. But we don't need theta to figure the sine of theta or any of the 6. Tell me what each of these is, starting at the top.
The sine of theta is opposite over hypotenuse, so would it be 12 over 20, so 6 tenths?
Yeah, we'll worry about simplifying it later. Or do you need to turn in these answers? I mean, or is this just more for understanding it?
This is more for just understanding.
Okay,
it's not
just go through them each then. Because I think it's really important to think about trig in a certain way. Trig always, you take a trig function of an angle to get a ratio. That's what you're getting, is a relationship between certain sides of a triangle, a right triangle. So that's the sine of theta, is that number. Now I haven't simplified it to give you a perfect fraction. That would be 3/5. But nonetheless, 12/20 is a correct answer. What's cosine of theta?
Adjacent over hypotenuse, so 16 over 20.
Tangent of theta?
That's opposite over adjacent, so 12/16.
Cosecant of theta?
Let's see here. Is that 16 over 12? Or not 16 over 12. 20 over 12.
Yeah, it's the reciprocal of sine. So whatever sine is, it's the reciprocal of it.
Okay.
Same thing with secant. Secant is the reciprocal of cosine. Those two are reciprocals. So what's secant of theta?
The secant of theta is going to be 20 over 16.
And even though I'm not sure it's right, myself, I tend to think of these last 3 functions as being somewhat secondary. Even though they're not, they're just as primary as the top three. It's just that whenever I think about cosecant, secant, and cotangent, I need to think first in my head is which ones are they reciprocals of? So these reciprocal relationships are extremely important. And let me just, so there's your answers, okay? But before we go on, let me get it so you can memorize these. I'm going to erase this triangle over here. It's a real easy way to memorize the reciprocal relationships.
All right.
Here's your three primary ones, right?
Yep.
What's the reciprocal of tangent?
Cotangent?
That's easy. Nobody's ever going to forget that. So the things that people forget are, does the secant go with sine or does it go with cosine? Well, it goes with cosine, which leaves the cosecant to go with sine. And notice that that's an S and a C, and that's a C and an S. So if you make a mistake and put cosecant with cosine, you're going to have two C's.
Okay. That actually makes a lot of sense.
Yeah,
Right.
you're never going to mess it up that way if you use this system. Unfortunately, it kind of locks your brain into thinking about cosecant as the reciprocal of sine, and that's the only way I'm almost capable of thinking about it. Now, obviously, if cosecant is the reciprocal of sine, then sine is, or cosecant also, that has to be true, right? There's x's in all of these. I just didn't write it.
Mm-hmm.
And in other words, there are 6 reciprocal relationships.
All right.
And you really only have to remember basically one thing. That's that the starting letters are different on the sine and the cosine for their reciprocal. Everything else is as you would think it would be.
Okay.
Okay. What else you got? You got a different triangle this time, or?
Yeah.
Wondering how much of this to erase. It kind of depends on what the next problem is. I can erase everything on the left over here.
Okay. So the next triangle, it's another right triangle, and one of the legs is 5. The hypotenuse is 5 root 2, and the angle between the leg and the hypotenuse is theta.
Let's make that 5 then and not theta. I like to kind of keep my thetas on the lower right. Now, we didn't answer one of the questions you had on the last question, which was what was theta, right?
Right.
Wasn't that one of the questions?
It just asked for the 6 trigonometric functions.
Oh, it didn't ask you for theta.
Mm-mm.
Well, which is kind of interesting if you think about it, because that's one of the most common right triangles in the world. That's the first right triangle they teach you when they're teaching you math, is the 3, 4, 5 triangle.
Okay.
Now, let's look at that again for a moment before we get to this new problem. That was our triangle, right?
Mm-hmm.
Only it was a 12, 16, 20, but nonetheless, theta's the same.
Yep.
And that's interesting to realize, is that theta is the same regardless of what multiple of a 3, 4, 5 triangle we have. It doesn't change theta, it just makes the triangle bigger or smaller. Have we taught you inverse trig functions yet?
Yeah, they have.
Okay, so theta would be the inverse sine of what?
Theta, in this case, would be the inverse sine of 3.
3,
Or, like,
3/5.
yeah.
Okay, here's something to remember. You're always taking trig functions of angles to get ratios. If I take the sine of 30 degrees, I get 1/2. That, by definition, means the inverse sine of 1/2 equals 30 degrees. So we're always taking trig functions of angles to get ratios, and we're always taking inverse trig functions of the ratios in order to solve for the angle. So if I wanted to know what theta was, it's the inverse sine of 3/5. That happens to be like 37 degrees, leaving this to be 53 degrees. But yeah, they spend 2 years teaching you this 3, 4, 5 right triangle, and nobody ever tells you what those two angles are. Because those angles aren't the important part of the triangle. The important part is that this is the smallest triangle, right triangle, that has integers as their sides. In other words, there's no 2, 3, 4 right triangle. There's no 1, 2, 3 right triangle. The smallest one is a 3, 4, 5. And the next smallest one is a 5, 12, 13. In other words, that's the second smallest perfect Pythagorean triangle. That one there. All right, now back to your problem. I backed up because I thought you had said that they wanted you to solve for theta also in the last problem, but maybe not. Okay, so here, again, they want the 6 trig functions, right?
Yep.
Just a second. What's this side right here that's undefined at the moment?
Would it be 5 as well?
Yeah. And there's a couple of ways you could solve the Pythagorean theorem, which would solve for that. But probably the easier way is to remember this special triangle that's a 1, 1, root 2 triangle. Okay? Now if you notice that that's a 5, 5 root 2, then the relationship between that and that is the same in your triangle. So that's got to be a 45-degree angle. If it is, that side's got to be 5, the same as this side.
All right.
So remember those two special triangles. There's a reason they're special. It's because of trig. In other words, on the 30/60, that side's 1, that side's square root of 3, that side's 2. So you get all of your trig functions from these two triangles. Now, by all of them, I mean all of the common ones. The ones they want you to know without a calculator are 30 degrees, 45 degrees, 60 degrees, 90 degrees, those kind of angles. They're never gonna say to you, what's the sine of 29 degrees without a calculator. Nobody knows that.
All right.
But they do expect you to know the 6 trig functions of 30, 45, and 60. And these two triangles here on the right are one way that you can always know them. What's the sine of 60 degrees?
Is it root 3?
Root 3 over 2. Remember, you always get ratios. Even if I say, what's the cosecant of 45 degrees? What is it?
Is it 2 over root 2?
It's root 2 over 1.
Root 2 over 1.
Yeah, now that kind of brings up an interesting question. If I said, what's the sine of 45? It would be 1 over root 2. Okay? And normally they would have you rationalize that, although the new trend in teaching trig is to not rationalize. And the reason is that if I want to know what the cosecant of 45 is, I'm far better off if I haven't rationalized that, right? It's that. Whereas if I've gone to the trouble of rationalizing that, I get square root of 2 over 2. Now if I say what the cosecant is, you'd say 2 over square root of 2 and have to rationalize it again. So the rationalization process tends to be a little self-defeating in trig. you're constantly wanting reciprocals because of this reciprocal nature of the other three trig functions. So having an irrational number in the denominator is not such a bad thing if I've got to figure out what the reciprocal of that is. Because the reciprocal, then that irrational number goes to the numerator automatically. So that's something to consider, and that's why I don't worry about rationalizing at all with trig. I'm perfectly willing to give this as an answer. Now, you might have a teacher that won't accept that, where you always have to give the answer rationalized, and that's fine. But even if that's the case, there's nothing that says you have to rationalize during the course of solving a problem. Maybe before you give a final answer, okay, I'll go along with rationalizing it. But even then, if you ask some trig teachers what's the sine of 45 degrees, they're perfectly happy with 1 over square root of 2. They don't care if you rationalize it or not.
All right.
All right, so back to our triangle over here. We figured out that it's an isosceles right triangle, which makes the two sides equal. Now tell me the 6 trig functions. What's the sine of theta?
So the sine would be 5 over 5 root 2.
Okay, now, do you know if your teacher's wanting you to rationalize or not?
I don't think she's too specific about it.
Okay.
But
if she doesn't say anything about it and you get away with that, it's worth finding out because you don't want to take a final test. Plus, your final test might be multiple choice, and that might not be one of the choices. So rationalize this for me and tell me what you get.
all right.
First of all, how do I rationalize?
You're taking the radical out of the denominator, so
How do you
you'd
do
multiply both by root 2?
Yeah, I don't need to multiply by 5 root 2. I just need to multiply top and bottom by root 2. And that gives me 5 root 2 in the top, and it gives me 5 times 2 in the bottom, or 10, which gives me root 2 over 2.
Okay.
So that's what the sine of theta is. And notice that's the same as 1 over root 2.
All right.
Okay.
That makes sense then.
So rationalizing is it's kind of a pain to have to do, and I'm not even certain why there's that math convention that everything can't have a irrational number in the denominator. I don't really understand necessarily why. If you put both of those numbers in a calculator, you get identical answers. So what's the cosine of theta?
5 over 5 root 2, so the same thing, root 2 over 2.
What's the tangent of theta?
5 over 5, so 1.
What's the cosecant of theta?
5 root 2 over 5, so root 2.
Right. What's the secant of theta?
Root 2 again.
And the cotangent of theta?
1.
Okay.
All right.
What else you got?
Another area of, or like the next part of it is on trigonometric functions of any angle.
Okay.
So whenever
unit circle. The unit circle.
Yeah.
You know what I'm talking about when I say that?
Yep.
Yeah, I would figure that they're not going to ask you all angles unless they've taught you the unit circle. So let's talk about the unit circle. A couple things they may not have taught you. All students take calculus. Means all 6 trig functions are positive in the first quadrant, only sine in the second, and it's reciprocal, obviously, only tangent in the third, and only cosine in the fourth. So what's your first question?
So it's asking evaluate the functions without using a calculator, and the first one is tangent 11 pi over 4.
Okay. First thing you want to do, let me put the rest of the information that's needed on this unit circle. The top is if you're in degrees, the bottom is if you're in radians.
Okay.
And it applies to whatever quadrant you're in. In other words, if I'm in the second quadrant, I'm going to use one of these. If I'm in the third, I'm going to use that one. And if I'm in the fourth, I'm going to use this. And what this formula that I'm writing does is translates your angle to what's called the reference angle, which is basically the equivalent first quadrant angle. In other words, if you know your two triangles, those two triangles give you all of the answers of your first quadrant answers. Notice that I can get my 30 and 60 degree from that triangle, and I can get my 45 degrees from this triangle.
Yep.
And if you can know the 6 trig functions of these three angles in the first quadrant, then figuring out every other quadrant is just a case of figuring out what the equivalent first quadrant angle is, and then figuring out what the plus or minus sign is. Okay, so that's the process we're going to use always.
All right.
Now, first thing is this is not in the unit circle. So we've got to find a coterminal angle to this that is in the unit circle. Now, I don't know if you've had this long enough that you can think in radians yet. Probably not. You're probably converting everything to degrees, and then if necessary back to radians. That's my guess.
For the most part, sometimes I know a few of the basic ones pretty well.
Okay, good. If I want to convert this to a unit circle angle, what do I have to do? What do I subtract?
Subtract?
Well, it's greater than a unit circle right now. Remember that 2 pi is one unit circle, which is 8 pi over 4. So this 11 pi over 4, that's more than 2 pi. So this angle is greater than 360 degrees. So my very first task is to put it inside the unit circle by subtracting 360 degrees from it, or 2 pi, or 8 pi over 4, because I need a common denominator.
All right.
And that gives you 3 pi over 4. And that's the angle we're dealing with. In other words, the tangent of 11 pi over 4 is the same exact answer as the tangent of 3 pi over 4.
Okay.
Now, let's finish labeling this thing. And this time I'm going to label it in radians. Which quadrant is 3 pi over 4 in?
It's in the second quadrant.
So which formula do I use to find its reference angle?
You would do 180 minus the...
Let's work in radians. That's this one here. The pi minus theta.
Okay.
So what's pi minus 3 pi over 4?
Pi minus 3 pi over 4?
Uh-huh. That's what this thing says, is that in order to figure out the reference angle, I'm going to subtract whatever angle they're giving me, which in this case is 3 pi over 4, from pi.
All right.
What do you
So
get?
then you would do...
You need a common denominator, so make it 4 pi over 4, that's the same as pi, minus 3 pi over 4. What's that give you?
Just pi over 4?
Okay. That's what angle, do you remember?
45 degrees.
Good. So when I'm doing these trig of angles that are not in the first quadrant, in parentheses I put what the reference angle is. Because I know how to find tangent of 45 degrees. I can look at that triangle. What's tangent of 45 degrees?
The tangent is pi over 4.
No, look at this triangle up here. What's the tangent of 45 degrees?
Oh, root 2 over 1.
No, opposite over adjacent.
Opposite over adjacent. Oh, just 1.
Just 1. And now we put the plus or minus sign on it. And the only thing I need to know is what quadrant it's in. We'll cross.
Second quadrant.
So what's its plus or minus sign?
It would be minus.
Correct. And that's how I do every problem you're going to give me. Exactly that way. So give me another one.
All right.
While we're hot, because I don't want to end this session without us doing a few of these, because by the time we're done tonight, in the next 4 minutes, you're going to know how to do every angle they give you.
Okay. The next one is cosine 11 pi over 6.
Is that in the unit circle or outside the unit circle?
Outside of it.
No, it's actually less than 2 pi. Remember the, yeah, the unit circle is 2 pi, so that's a number less than 2 pi. Now, tell me, what quadrant is it in?
It would be in the 4th quadrant.
So what's its reference angle?
Its reference angle is 3. Oh wait, sorry, 360.
Leave it in radians. Leave it in radians. Remember, it's going to be 2 pi minus that angle.
Yep. So.
How short of 2 pi are we?
We're 1 short, or 1.
Okay, that's the reference angle. In other words, 2 pi minus 11 pi over 6 is pi over 6. In other words, I've got to convert this 2 pi into 12 pi over 6, a common denominator, before I can subtract these. Okay? So, now that I know my reference angle, what's cosine of pi over 6? What angle is pi over 6?
Pi over 6 is 30 degrees.
Now look at this triangle up here. What's the cosine of 30 degrees?
Root 3 over 2.
And now we are in the 4th quadrant. What is the sign, plus or minus sign on that thing?
Plus.
Perfect. That's the way you do it. Now, you got another one?
The other ones are in degrees instead of radians.
That's all right. Let's do at least one more.
All right. The next one is secant of 225 degrees.
What's the reference angle?
The reference angle?
What quadrant is that in?
It's in the 3rd quadrant.
Okay, so what's the reference angle? This time you use this formula.
Yep. So 225 minus 180.
It's 45. Now, go over to your 45 triangle and tell me what the secant of 45 is.
Secant of 45 is root 2 over 1. Or is it 1 over root 2?
No, you're right. It's root 2 over 1. It's the reciprocal of cosine. Cosine would be 1 over root 2. So secant is root 2 over 1. But we're not quite done yet. We need to put its plus or minus sign on there. What quadrant are we in?
We're in the 3rd quadrant.
What's the sign of secant in the 3rd quadrant? I hate the fact that sin has 2 different meanings here. What is the plus or minus sign on the secant in the 3rd quadrant?
It would be minus.
Again, that's the steps I use every single time. I never put the minus first. Always figure out the number first, Then I figure out the quadrant and what its plus or minus sign should be, based on all students take calculus. Now, if you're looking to memorize anything in trig, memorize everything you're looking at on the page right now. In fact, it'd be worth taking a picture of this screenshot or saving it, because this picture will answer all 6 trig functions as long as they are multiples of 30, 45, or 60 degrees. Now, the one thing it will not answer is your quadrangles, which is another 10-minute topic, but probably more than we have time for tonight. In other words, figuring out what the sine of 90 and 180 and 270 are is a little more difficult because you can't just use these triangles. You got to add additional information to it. But everything you see on this page you're going to want to memorize. And I mean that. At some point. Maybe not this year because they're just giving you a taste of trig, but it sounds like they're giving you a pretty good taste. In other words, you're getting quite a bit of trig here. If they're getting into the unit circle, that's quite a bit. You're just taking Algebra 1, aren't you?
I'm in Algebra 2 trig.
What am I thinking? Okay. Sorry. I was thinking, boy, this is a lot of trig to be given an Algebra 1 student. They've really changed the core curriculum here. But no, in Algebra 2 trig, this makes much more sense that you'd be getting this much trig. And you're in the trig portion now. So yeah, that's why they've taught you inverse trig functions and all of that good stuff. But for sure, memorize that page right there.
All right.
Everything on it.
Yep, I just got a picture of it.
Good. And that, I guarantee you, will let you answer any trig function or any angle that is a multiple of 30, 45, or 60.
All right.
All right, Morgan, I will talk to you next time.
Okay, thank you so much.
You're welcome.